given f of x equals x squared minus 2x minus 8, and the part A says to graph this. So what we're going to do first is I'm just going to put it in that standard form or vertex form, whatever you want to call it, so that we can actually do a simple, quick graph of this. We don't have to graph it specifically with all those values and stuff in there, because when you look at part B, part C, part D, we're going to have to deal with a little bit more there. But if we put it in vertex form, we'll get a lot of information fairly quick. So that's what we're going to do. So then my f of x is going to equal, now I'm going to separate the variable terms there, and then I'm going to do completing the square again. Fix my 8 there. So I'm going to take half of b and square it, and that's going to give me a 1. So I need to add a 1 in there. Now there's no multiplier on it, and that makes it really nice to work with here. So I'm going to have to add that 1 in there. So that's going to result in x squared minus 2x plus 1. And then since I added a 1 in there, I'm going to have to subtract a 1 out here, so that if I put them back together, I would get that 0 for those two values that I introduced here. And then this here is now a perfect square trinomial, and when I factor it, it's going to be the x minus 1 squared minus 9. So that's what my function is now in form there. And now I can tell what this is very easily in a graph. So right away I know my vertex is 1, 9, or 1, negative 9. So 1 and then down 9, so that puts me here. That's my vertex. I know when I go to the right one, I go up 1 because there's no multiplier on my x here, so that's going to be here. And then because of symmetry, this equation of the axis of symmetry here, I know that I'm also going to have 1 here because of symmetry. And that's my y-intercept. Very easily achievable there. And then I can find out my x-intercept's actually really easy here too. Because what do? I make my f of x 0. So I really just have the equation x minus 1 squared minus 9 equals 0. I move the 9 over, so that's x minus 1 squared equals 9, and then I square root both sides. So I get x minus 1 equals plus or minus square root of 9. And the square root of 9 is 3, so I really get x minus 1 equals plus or minus 3. So then when I move the 1 over, I'm going to get x equals 4. Or when I move the 1 over, I'm adding 1 here. So if I use the negative 3 now, and I add the 1, that's going to actually make it negative 2. So those are going to be my x-intercepts, 4, 0, and negative 2, 0. So at 4, 0, there's a point there. And at negative 2, 0, which is here. Now I have enough information to graph this. And I knew this opened upward because my leading coefficient was positive. And again, that's more of a complement to the information that I find than actually using it directly. So it's very nice. So there's my graph of my function, f of x. So it was very easy to put all that information together when it's in this vertex form. Makes it easier. So anyways, now let's get to part B here. Now part B says determine the domain and the range of the function. So the domain is very easy because notice this, it's on an angle here. So I'm going to go all the way right and all the way left and everything in between. Because remember, this x-axis is how I measure my domain. So that means it's going to be negative infinity to infinity. And I should write down and label that I'm talking about my domain here. So then when I do my range, there's no confusion. So my range is all my y values. So what I do is that you notice it keeps going upward. So it's going to be all the way up, all the way down to here. And that value happens to be negative 9. So that means, since I'm talking about the range here, all my y values, it's going to go from and it includes a negative 9, so I use a bracket, all the way to infinity. And infinity, remember, we always use a parenthesis for that. Okay, now part C says, determine whether the function is increasing. Determine where the function is increasing, excuse me. So it's increasing after x equals 1. Now remember, when I'm talking about the idea of increasing and decreasing, I'm always using x values as my perspective. So I'll say x from this value to that value. If I'm talking about domain, I use my x values. My range, I use my y values. But mostly when I'm talking about things for functions, the characteristics, it's mostly I'm using it in perspective with the x values. So any increasing, decreasing, all those things in terms of the x's. So in a sense, I think of like, hey, all the way from here, all the way out with my x values. So then that would be 1. And I never include the n values because it's not increasing at 1. But after 1, it is increasing. So I will say 1 to infinity. It's increasing. And remember, for it to be increasing, if I pick a value, so let's say I pick 2, and I go to the right of that value, let's say I pick 4, is the y value larger at that second point? And it would be on the right of 1. So just that's how we actually assess it. So increasing simply means, is the y value larger? So if I picked any 2 points, let's say I pick this one here, and then I pick this point here. Now I don't know what that point is, but I can easily see that that y value here is larger than the other y value because it's higher up the y-axis. So that tells me that it's larger. So that's all I have to do for increasing. Now then for decreasing, it'll be the opposite of that. So as I go from left to right, are my y values getting smaller? And they do, from negative infinity to 1. Because if I pick this value here and this value here, now as I go to the left, the y values are getting smaller. They're getting closer to negative 9. So that's how that works. So that's all my information for this problem here. It only asks those 4 things. So there we go.